All right, welcome to the engineering class for October the 27th. Right before I turned on the recording, somebody asked a question about homework. Last time we met, I did want you to kind of play with the code, and some of you showed me your creation before the class ended, and others of you hadn't quite finished when class ended, and so I asked you to just send it to me so I could see what your creation was. It wasn't really an official homework assignment. Um, all right, so the new term has started. We are almost finished with the section of the class that deals with software engineering. Although we're going to be coming back to it, because the next thing we're going to be doing after we finish today is next time we meet, we're going to start into electrical engineering, and many of the creations that we come up with for our electrical engineering project are going to be driven by an Arduino, and that Arduino has to be programmed. So we will be using the software engineering skills that we've hopefully developed over the last little while. But I'm going to keep it pretty simple. Up until now, pretty much everything that we've done has been done using the drag and drop blocks rather than actually writing the real code. So what I want to do today is I'm going to give you an assignment that part of the assignment cannot be done using the drag and drop blocks. But if you were to create it using the drag and drop blocks, you could quite easily modify it. You could take the code that you get from using the drag and drop blocks, and then open up that code and then just make a few changes in that code. And that would accomplish one of the things that I'm going to have you do today. And then there's another thing that I'm going to have you do today that could be done using the drag and drop blocks, but it could be done so much more efficiently by using the real code, right? So that's the two goals for what we're going to do today. All right, so let's go in here. Let me share a screen with you, and I'm going to show you a circuit with an Arduino that I have created that accomplishes a certain goal. And I'm going to have you guys duplicate that. So let's go into Tinkercad. All right, I'll go into circuits. And I have one here that says automated SOS sender. All righty. Okay, so the way this thing works is it's intended to be an automated distress signal. So let's suppose that you're out sailing across the ocean or whatever, and you run into trouble and your boat starts sinking. And so you don't have time to sit there on the radio calling for help. You're trying to stop the boat from sinking, right? But you definitely want to send out an emergency distress call. So how can you do both at the same time? Well, what you do is you design an emergency automated SOS sender. So basically the way it works is you push a button and then it will automatically send out an SOS signal, and it'll just repeat SOS, SOS, and it'll do that automatically so that you can deal with the whatever it is that's causing your boat to sink, and if you're lucky, maybe prevent the boat from sinking. Okay, but you want to be sending out a distress signal meanwhile. Okay, so what we have here is a circuit that has a light on it, has a buzzer on it, and I have programmed it so that so when we activate it, it'll send out the automated SOS, and it'll just keep sending out SOS, SOS. By the way, you guys know Morse code for SOS? Okay. Somebody unmute yourself and tell us, what is Morse code for SOS?
Dot 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 dash 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 dot dot dot.
Very good, you got it. Okay, good. And so we want to just keep sending that out over and over and over again. All right, so what this is going to do is it's going to send out SOS both by the beeper and also by the light. And actually what you'd be doing is you'd be sending it out over the radio, but okay. All right, so now there is one thing though. You don't want to accidentally send out a false alarm. That's really bad. The Coast Guard will really come down on you hard. If you're out sailing and you call Mayday when it's not really a Mayday situation, the Coast Guard can issue some pretty stiff fines because if you call in a false alarm and they send out all the people and all the equipment and everything like that, turns out to be a false alarm, yeah, they get really upset with good justification. So in order to avoid accidentally sending out false alarms, I've got this thing programmed so that when we start the simulation, it'll give me a little countdown. It'll give me 5 beeps and then 4 beeps and then 3 beeps and then 2 beeps and then 1 beep, so that if I were to accidentally activate this thing, I would hear the countdown, I would hear the beeping, and I would have time to say, oops, I didn't mean to do that. And so then I'd have time to stop it, right? So it's a good idea to have this kind of a little buffer. It's kind of like on your computer when you delete something and it says, are you sure? Right? It's kind of the same thing here. When I push the SOS button, this is my way of saying, are you sure you really want to send it out? Okay, so let's start the simulation. Let's see what happens. Okay, there's 5 beeps, 4 beeps, 3 beeps, and also flashes, 2, 1. Okay, so since I didn't stop it, so now it goes into mode. So it's sending out SOS. Okay, so 3 short, 3 long, 3 short. And it just keeps sending that out now forever and ever and ever and ever. All right. Okay, pretty straightforward. All right. So your job today is going to be to create this, and this will count as an assignment. I haven't entered it into SIS yet, but I will really quickly. So before the day is over, I'll have a thing in SIS where I want you to create this circuit, and then I want you to go up here to where it says share, and then I want you to invite people, and then I want you to copy the link there like we've done before. Okay, but if you try to create this using the drag and drop software, you're going to run into a problem. What's going to happen is that if you create that countdown, the 5, 4, 3, 2, 1, using the drag and drop software, and then you do the SOS following that using the drag and drop software, the drag and drop software puts it all in the part of the program that we call the void loop. Remember when we looked at the code, after we did the drag and drop and I said, I want you to look at the code, you'll remember that the structure of the code for an Arduino is you have a thing where it says void setup, open parenthesis, close parenthesis, and then there's an open bracket, and then there's the code, and then there's a close bracket, okay? And then down below that, there's another part where it says void loop, and open parenthesis, close parenthesis, open bracket, and then there's all the stuff that goes in the loop party code and then close bracket. Okay, so this, the void loop follows the void setup. And then also before the void setup, there's the place where you can declare your variables. So if you intend to use a variable that's going to be I, you want to declare that variable up here. So you call it int I equals, and then you can give it some starting value. Okay. All right. So hopefully you remember that when we looked at the code, we saw that the code was structured like this. So there is the void setup part and the void loop part. And the void setup part only runs once. So it's something that runs at the very beginning of the code, and then it never runs again until you stop the Arduino and restart the Arduino. And so this is the one, the void loop part. That's the part that runs again and again and again until you turn off the Arduino. It'll just keep on repeating forever if you leave the Arduino on forever. Okay, so that countdown that I told you that you saw where it went 5 and then 4 and then 3 and then 2, then 1? Okay, you only want that to do that one time. If you create that using the drag and drop part of the software, it will, oops, I didn't mean to clear everything. That was my, oh, I hate it when I do that. Okay, so the setup and then the loop. Okay, and then you have to have void in front of it. Okay, so if you create something using the drag and drop software, it puts it in the loop part of the code. So if you were to try and create what I just did using the drag and drop, you'd get your 5, 4, 3, 2, 1 countdown, and then you get an SOS, and then you'd get another 5, 4, 3, 1 countdown and another SOS. And so what you need to do is you need to put that countdown part in the setup part of the code and put the SOS part in the loop part of the code. Okay, so you could either write the code from scratch, or if you're uncomfortable writing the code from scratch, what you can do is you can create it using the drag and drop. And then once it's created, what you can, so the drag and drop is going to put the countdown part in here. So once it's created, then you can just take this and just copy and paste, and just move it up, cut and paste and just move it up in there. That'll work. Okay. And so what I'd like you guys to do right now is to take a few minutes and do that. And then the second part of the assignment where I told you that there's a way that you can do it a lot more efficiently. Well, I'm going to hold off on that. I want you, let's do one step first before we do the other. All right, so this is the assignment that I want you guys to do, is I want you to go into Tinkercad. I want you to create a circuit that looks like this. All right, so we're going to have an Arduino. We're going to have an LED. And I don't care what color you want the LED. You can make the color red, or if you want to make it some other color, yeah, I'm okay with that. This resistor right here, you don't have to have it. It is recommended. As we hopefully learned last time, if you leave out the Arduino, if you leave out the resistor, you won't immediately destroy your LED, but you will reduce its lifetime. So let's get in the habit of using the resistor. And then the next thing that we do after we finish up this software engineering project is we're going to learn why that resistor needs to be there and how to calculate the value. But for right now, you see, if you look over here, you can type in a number for what you want the resistor to be. So let's everybody agree that we're going to use a 220 ohm resistor. And by the way, over here, if you click on this, it gives you different values. So you can put it in as 220 kilo ohms if you want, but that wouldn't be good because then your LED won't light up. You could even go 220 mega ohms or even 220 giga ohms if you wanted. But let's just go with regular ohms. And by the way, that upside down horseshoe symbol, that's something we're going to be talking about next time. So just put it on the regular old ohms. And that's what the upside down horseshoe means, is ohms. So put it on regular ohms. Don't put it on milliohms or microohms or anything like that. Put it on regular ohms, 220. Okay, and then bring in a speaker, or the little buzzer right here. Piezo buzzer is what you want. So just pull that in there like that. Once you get it in there, you can't get rid of it unless you delete it. Okay, and connect it up. And so then I want you to use the drag and drop software to create it so it does the 5 beeps, 4, 3, 2, 1, and then I want it to do SOS. Okay, do you guys remember enough of how the drag and drop so that you think you could do that? Okay, now when I share my screen here, the chat box goes away. So I'm going to have to stop sharing here. Okay. So is there anybody who wants to ask a question before I have you do that? And now stay in the class here. Don't type by and go away, because I want to be here so I can help you overcome any problems that you have. And then after most people have got it, then we're going to go into the part 2, where I'm going to show you how it is that if you had done it using the real code instead of the drag and drop, you could have done it so much more efficiently. But it builds character to do things the hard way, right? Builds character. Okay, so Ahmed, do you have a question that you want to ask before I turn you loose? Those of you that think you know how to do this, go ahead and fire up Tinkercad and get working on it. And Ahmed or anybody else has a question, go ahead and ask your question.
How do you get the board on the design, like
Okay.
the
So,
the Arduino board?
okay, so let me go to a brand new thing. So we'll go to Tinkercad. And we're on, now when you go into Tinkercad, it's going to have you on 3D circuits, so 3D design. So you have to go down to circuits. Okay. And you're going to create a new circuit. And you're going to wait a few seconds. Okay, there you go. All right. So what you can do is if you come over to the right here and you scroll down, there's the Arduino right there. So click on that and drag it in. So there's an Arduino. And it'll come in with no code, but that's okay. That's what you want. And then also we want to get a piezo. So that's the little speaker. So bring that, drag that in here. And also we're going to want to get an LED. So bring that in there. And also we're going to want to get a resistor. Okay. So just drag them in like that. And then when you hook them up, if you click, so if you zoom in here, if you click on the terminal there, then it gives you a wire. So you can hook it up like this. So make sure that you connect it up so that the wire that comes out of the Arduino goes through the resistor and then it into the right side of the LED. And then on the left side, that's where you want to go to ground. If with these LEDs, if you hook them up backwards, they won't work. And then do the same thing with the piezo. Okay, so one of the piezo leads, it says positive and the other one says negative. So the one that says positive, hook up a wire from there to any pin. I don't care which pin you use. And then on the right side where it says negative, you need to hook that up in. Now what you could do is you could hook this up into the same ground where the LED is. You could do that. Or if you come down lower here, you'll see that there is a ground down here. So hang on a sec. I've got something on my screen that you guys don't have that I need this in my way here. Okay, so if you click on here, you'll see that there are 2 extra ground pins down here on the bottom. So you could, I would recommend you put it in there.
Okay.
And now you're ready to start writing your code.
Thank you.
Yeah. And I'm going to pause the recording because there's no reason to keep recording while you guys are just doing this. Does anybody have anything yet that you can share? All right, Dons, can you, here, let me enable sharing here. Okay, so you now have the ability to share your screen.
I'd rather not share my screen now, but I can share the link.
You have the ability to share your screen.
I'd rather not do that right now, but I can share the link.
Oh, you'd rather not do it, but you can share the link. Okay. Is all right then if I click on the link and I share it? Are you okay with me doing that?
Yeah.
Oh, okay. All right. I'm not sure I understand that, but I won't argue with it. Okay, so let me share that. Let's see. Now, is this one mine or is this one yours? Okay, that must be yours because I see it's being changed and I'm not doing the changing. All right, so let me share the sound here. Okay, let's click on it and let's see what happens. Five, 4, 3, 2, 1. Good. Okay, very good. And let's see if it repeats it again. All right, excellent. Do you hear that? So that's the SOS. All right. I'll go ahead and stop that. Okay, so Don's has successfully done the job. Let's look at the code and see how he did it. All right. So I see he has setup code here where he is declared the pins as outputs. And notice the way that Don's did this here. This is the efficient way to do it. Don's clearly has some experience here using computer programming. He has taken 2 for loops and he's nested them together so that it starts off with x at equals 0. And then it's going to count up and it's going to stop until it gets to 5. So we're going to go through a loop here, starting at 0, going to 5. And then we got an inner loop here that starts at 5 and counts down until it gets to whatever x is at that particular loop. All right, and then he's got high. Okay, so it looks like he has defined some functions here. Wow. Okay, so this is exactly where I wanted to go at the end of the period. So looks he's jumped right to it. So what he has done is he has defined some functions where one of his functions is called high. And what it does is it writes 13 high and then it sends the tone. And then he's got another function that he has defined that's just called low, which writes a low and then it turns off the tone here. Okay, so Don's has done it in the advanced way. And this is the way that I was planning on showing to everybody after we had first done it the more simple way. So good for you, Don's, you are ahead of the game. So let's see if somebody else did it in the more simple way. And when I say simple, I mean that it's conceptually more simple, but it turns out that it's more work because you have to do lots more lines of code. All right, so so I see Marshall is the next one in line here. Marshall, would you be willing to share yours and talk about it? So Marshall, you should have the ability to share your screen right now. Okay, good. All right, so let's see what he's got. Oh, it looks like he has an error in his code somewhere. Oh, ouch, hate when that happens. Okay, so Marshall, looks like you need to do a little more debugging. So go ahead and stop sharing. And let's see, who else was next in line here? Presley. Okay.
I just fixed it. I misspelled something.
Oh, okay, all right. Okay, let's see if Marshall's got it now. Okay, so he's got the sound turned off, but that's okay because we can see that the beeper is going there. So 3. Okay, that looks like a long. Okay. Okay, I'm not seeing anything happening right now.
The LED is going.
Oh, there's the LED. Can you zoom in so that we can see that? Okay, good, thanks. Okay, and then zoom in just a little bit more. Okay, and you guys see that red button, Marshall? You know the reset button, right? Okay, yeah. Oh, you had it. Yeah, right. Okay, that's it right there. Okay, now don't push it just yet, but hang on just a sec. All right, so that button there is a reset button that Marshall knows about because Marshall took my engineering class. So I want him to put, in a minute, I'm going to ask him to push the reset button, and then I'm going to want to see if it does the countdown right. Now he doesn't have the sound enabled, so we can't hear the buzzer, but you can see when the buzzer goes. All right, Marshall, I'm ready to hit for you to hit reset there. Okay, so B 2, 3, 4, 5. Pause. 1, 2, 3, 4. Pause. 1, 2, 3. Pause. 1, 2. Pause. 1. Okay, very good. That's the countdown. All right, now there's our SOS. Okay, that was the S. Here comes the O. Good. Next is the S. Okay, so we had 3 long, 3 short, or 3 short, 3 long, 3 short. Now we're doing 3 short again. And there's the 3 long. Okay, very good, Marshall. Congratulations. Now, can you stop the simulation there? Oh, wait, I wanted to see how you did it. Go ahead and share your screen again there, Marshall. I'm not done with you. Okay, so stop the simulation. Okay, yeah, and then show the code. Okay. All right, so now we want to see how he did it. And boy, it's really small there, isn't it? Let me get my glasses and lean in really close. Okay, so it looks like Marshall used a for loop. Okay, so Marshall used a for loop where he counted to 5. Hey, Marshall, can you highlight the for loop? Yeah, right there, and then the whole loop. Go down. Okay, good, perfect. Okay, so in that for loop, Marshall counted to 5. All right, and then Marshall had another for loop, so highlight that one. Good, thank you. Okay, so this one counts to 4, and then the next one, okay, and then 3, and then so forth and so on. So Marshall chose to do this using 5 different for loops. Do you remember the way that Don's did it? Don's did it using a nested for loop, which is much more advanced, but Marshall's way works just as well. It requires more lines of code. And Marshall's way is conceptually easier to understand. That's why I like Marshall's way. But Don's way is actually more efficient. It's just a little bit harder for a beginner to understand. Okay, and then if we go down to the bottom here, show us how you did your S here. So, okay, so, all right, so there is the for loop where he's doing the S, where you see the delay is for 500 milliseconds. Now highlight the one that shows us the O. Okay, very good. All right, so notice this time the delay is 1000 milliseconds, and then show us the final S again. Okay, good, very good. All right, and notice how the SOS is included in the loop part of the code, whereas the countdown was included up in the setup part of the code. All right, thank you, Marshall. That's great. That's a nice, simple, straightforward way to do it. All right, so now Presley, can you share yours?
Sure.
Okay, so first, okay, so 1, 2, 3, 4, 5. Pause. 1, 2, 3, 4. Pause. 1, 2, 3. Pause. 1, 2. Pause. 1. And now it should start into the SOS part. So there's that dot dot dash 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 dot dot dot. And then let's wait a second. I want to see if it repeats. Okay, dot 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 dot. Okay, 3 dots, dash 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 dot dot dot. Perfect. Very good, Presley. Nice job. Let's see your code. Let's see how Presley chose to do it. Okay, so he's got all those variables being initialized. Oh, hey, wait a minute here, Presley. How is the countdown? If the countdown is in the loop part of your code, then the countdown should have gotten repeated. How did you make it so the countdown didn't get repeated?
So I actually decided to use a variable in order to make this work.
Uh-huh.
So up here you can see k equals 0. That is the only variable I needed to use. So once it gets through
Oh.
all this,
Then it
and
sets K to
then-
1.
while k equals 0, this
Ah,
will keep repeating forever.
uh-huh. And then somewhere in here you set K to not equal. Okay, okay, very good. Oh, that's a clever way to do that. I like that, Presley. Okay, so what I was expecting everybody to do was to take the countdown and put it up in the setup part of the code. But Presley says, and he's right in saying, we don't need to do it that way. There's another way we can do it. Yeah, and he's absolutely right. So good for you, Presley. I really like it. I love it when people come up with creative new ways to solve problems. Good job. Okay. Now, so everybody stop working on what you're doing for a second and come back here. So what I'm going to do now is I'm going to show you my code, and what you're going to find is that my code is similar to the way that Don's did it. So I want to show you my code, and I want to explain a couple things about it. And then after that, I'm going to turn you loose. And so the rest of the period, I want everybody to finish up this assignment. And now on Canvas, I have not yet opened up an assignment for you to submit it, but before the day is over, I will open up something on Canvas, and what I'm going to want you to do is submit a link so that I can see it. But before you do that, let me show you the way that I did it. Okay. All right. So let me go back in here. I have another file in here that that did it in the more efficient way. So this file that you see here that says SOS with function call, that's the one. And I am going to share this with you. So right here, I'm going to copy that link and I'm going to share it with you in just a minute. But before I do that, let me just click on Tinker It so you can see how it works. Come on. All right. So here is the code. And what you're going to see is that I did it kind of the way that Don's did it. So in the setup part of the code, that's where I did the countdown. And you see what I've highlighted right there? Those 7 lines of code accomplish the same thing that Marshall and Presley did using like about 30 lines of code. It's a nested for loop. So I start a for loop going, and then inside of that for loop, I do the other one, and the inner for loop, it starts at count equals 0, and then it goes until it reaches J. Now, what is J? Well, J is determined by the outer for loop. So the outer loop starts at 5, and then it counts down. You see this command right here. This tells it to count down rather than counting up. So it starts off at J equals 5. So then it goes into this inner loop. So this inner loop is going to start at 0, and it's going to go up until it reaches whatever J is. And the first time through it, it's going to be 5 times. So what it's going to do is it's going to repeat this function here that I call beep and flash, which I'll talk about in just a minute. But basically, it's one line of code that both turns on the beeper and flashes the LED at the same time. And I can do it with one line of code. And so it's going to do this 5 times. And then it finishes the inner loop. And so then it comes to the outer loop. And so the outer loop now, J is no longer 5, J is now 4. So when we go into the inner loop a second time, it's going to start at 0 and it's going to go until it reaches J. But this time, J is not 5 anymore, J is 4 now. So and then it's going to do this 4 times, and then it's going to do 3 times, then 2. So this is called a nested for loop. It's very, very cool, very efficient. Okay, so I did this in the setup part of the code, and if you're using the drag and drop software, it won't let you do it in the setup. The drag and drop forces everything to go into the loop. So what you can do is, if you want, you can create it using the drag and drop, and then all of this part will be down in the loop part. And then what you can do is you can just cut and paste and put it up here. Okay, but now let's take a minute. Let's talk about this command that I created called beep and flash. So what I did was I defined my own function. And if you go down to the bottom after the loop part of the code ends, okay, this is all the loop part. Down here, you see this is where I defined my function. And so my function is called beep and flash. And my function can accept a number. So up here, you'll notice when I call beep and flash, I put a number inside the parentheses. So up until now, we've never really dealt with those parentheses and why do those parentheses need to be there. But now you see why they're there. Because if you put a number inside those parentheses, so when I call beep and flash, if I put 150 in there, then in the beep and flash definition, whatever number it receives, it's going to put it into a variable that I've called T. And then what it's going to do here is it's going to turn on pin 13, and then it's going to sound a tone, and the tone is going to sound for the amount of time that's determined by T. So when I call this function up here, if I say beep and flash 150, then T becomes 150. So what it'll do is it'll turn on pin 13 and it'll turn on the tone for 150 milliseconds, okay? And then it'll delay for the amount of time that's determined by whatever is T plus 100, because I wanted to put a little extra in there, okay? And then it's going to turn off the light, and then it's going to delay again for, again, the amount of time that I told it is T. So all of this code that you see right here, I can execute all of that code in one line. By up here, I just say beep and flash 150. And so this is the dot part of it. And you'll notice I've put it inside of a for loop here, where the for loop starts at 0 and it goes until it reaches 3. So by putting it up here, just those 3 lines of code allow me to do dot, dot, dot. And then down here, I've got 3 lines of code where this time you'll notice that when I called beep and flash, this time I told it I wanted 500 rather than 150. So these 3 lines of code are going to make my light and my buzzer come on, and they're going to stay on for 500 milliseconds this time. And then down here, they're on for 150 again. So this is a very, very, very efficient way to do the SOS using way fewer lines of code. So the trick here is by defining something that's called a function. And this is something that you can't do in the drag and drop software. You have to use the real code if you want to do functions and things like this. Okay, so what I'm going to do right now, guys, is I am going to type into the chat box. I'm going to put that link in the chat box, if it'll let me. There it is. Okay. So bingo. Okay, so what I just put into the chat box is a link that you guys can use if you want to go in and look at my code. Now, you won't be able to change the original file, but what you can do is you can make a copy of it and then you can change your copy. Now, I'm not saying that you have to make your code using the tricks that I have just done. If you want to do your code the more simple way, at least the more conceptually simple way, the way that Marshall and Presley did it, that's fine. That works perfectly fine. But if you'd like to play around with some more advanced coding, then look at the way that I did it, but please don't copy me exactly, okay? And then, so I will open up a Canvas assignment. In fact, I'll do that as soon as I finish talking. I'll open up a Canvas assignment, and then your job will be to upload the link to your creation so that I can verify that it works. All right, so is everybody clear on that? Okay, it looks like Presley just shared his code. Okay, but Presley, you understand that I don't want you to
I didn't
share.
share my code. You accidentally sent it in a private message to me.
Oh, oh, okay. Yes, you are right. When I sent the code out, I thought I was sending it to everybody, but I actually sent it in a private message to Presley. Okay. All right. So now, does everybody have the link now? Thank you, Presley. That's almost a wig point, but No, I don't think it's serious. Okay. All right. So if you understand what you need to do, then you can go ahead and type bye into the chat box, and I'll see you guys later. And if you have any questions, stick around and ask your questions. And I'll go ahead and turn off the recording so you can ask questions without it being recorded.